Hey everybody, this is a video response to Patrick JMT's problem that he put on his video, and basically this is another optimization problem where he's asking us to prove Snell's law. Um, yeah, okay. So what is Snell's law? Snell's law is refraction. In all sense, it's refraction. It tells you the refractive indices of certain materials, and he discovered this actually before calculus, or he used a very simple method, but it turned out to be correct, and many people proved it later. And we're going to use Fermat's method to prove it. Um, Step one, like in the last video, is to draw a diagram. Now, this was already done for us by Mr. Patrick, so not much work there. Um, if you don't know okay, I'll just restate the question for you guys. He's saying if you fire a light beam from here to, sorry, just straight from here, and it'll travel, travel, travel. Let's just say this is air. Travels through the air, hits the surface here. Let's just say anything below this line is glass. Speed of light changes in different mediums, so it bends. Travels here. Now, something I haven't written here is that this is v1. It travels here at velocity v1. Travels here at a velocity v2. Okay. We want to find the shortest amount of time it takes to get from here to here. Many of you might think it's just a straight line like this, but that's not the case. Okay, step 2. Assign variables. Now you'll see here I've made this whole thing y, I've made this x, and I've made this y minus x. I've done it this way because later on in step 4 you'll have to make everything one variable, and so I prefer to do it right now. Yeah, so everything is in terms of x, and I'll tell you more about that later. Step 3, relate the variables. Now if you recall, speed equals distance over time. So v, velocity or speed, they're not technically the same thing, but velocity is equal to displacement actually over time. So time equals displacement over velocity. Okay, so L1, using Pythagoras, L1 is x squared, square root of x squared plus a squared. L2 is square root of y minus x squared plus b squared. Okay, and looking here, time 1, this is going to be time 1. The time it takes to get from here to here is going to be the distance over the speed, which is v1. So time 1 equals L1 over v1. T1 is equal to, substitute this into here, and you get T1 is equal to square root of a squared plus x squared over v1. T2 is equal to L2 over v2 in a similar fashion, L2 over v2, and substitute that into here, and you get T2. Now the total time it takes is obviously time it takes to get from here to here plus the time it takes to get from here to here. So just T1 plus T2, substitute the values back in, and you get this. This is the function we'll be using. Now step 4 is to eliminate extra variables normally, but what you remember in this question is that we're proving something, we're not solving for a certain number. So we can take all of these, a, v1, b, v2, and y, as constants. We can treat them as constants, which only leaves us with x as a variable. If we were solving for a value, it would be a different matter, but then we would get values to put in the certain areas. Okay, so this is the function we will be differentiating. Step 5, here we go. Calculus time. We're going to find the derivative of the function of time. So t prime theta, this should be a t prime x, because x is the variable, is equal to dt over dx, Leibniz notation. Again, I said 1 over v1 is a constant, you can take it out. Differentiate this term, same thing here, and differentiate this term. Okay, so one thing you'll notice here, one thing you'll notice here is that this is a negative, and you'll be wondering why it's a negative. The thing you have to remember is that we're differentiating this whole term here and this term here. So you chain rule this and you chain rule the whole thing. Chain rule the whole thing, you get the 1 over 2u, and chain rule this, you get, since y is a constant, this becomes 0 and this becomes -1. So that's why you get the negative. Carried on here, you cross out the 2's, and this is the simplified derivative. So now we equate the derivative to 0 and we solve. So here we go. We equate it to 0. We move, you don't even need to solve actually. You move this to the other side, and now comes the interesting part. You'll see that x is, let's just go back here. Sine of a, sine alpha, is x over L1, right? Sine of beta is y minus x over L2. Okay, let's go back here. X over, and if you remember, square root of a squared plus x squared is L1. So this is 1 over v1 times x over L1. X over L1 is sine alpha. Same thing here. Y minus x over square root of b squared plus y minus x squared, which is sine beta. So 1 over v1 times sine alpha equals 1 over v2 times sine beta. Multiply in. Sine alpha over v1 equals sine beta over v2. This is Snell's law, and we've just proven it using calculus. Now normally when you're solving for a value, you would substitute that value back into the formula, but in this case it's not needed, as we're just proving. And let's move on to step 8. Tell everyone the answer. Yep, go ahead and just show your math skills with this proof. Now this is a formal proof of Snell's law, and there are a few other ways to prove it, like using Maxwell's wave equations, but you'd have to look into that to see it. And yeah, that's it. Thank you very much for watching. If you have any questions, please put them in the comments section. I'll try and answer them the best way I can. See you later.